Okay, so members, in this lesson, let us see how do we show that points are collinear and also how do we show that two vectors are parallel. For vectors, they are parallel. For points are collinear. Let us see what we do. In vectors, if two vectors A and B are parallel, then this one means that you can express vector A and B as scalar multiples of the other. So this one shows that vector A is a scalar multiple of vector B. The same thing, or you can express B in terms of A. This lambda and this K are real numbers, they are just figures. Then collinear points. If two or more points lie on the same line, then those points are said to be collinear. So you see that if A, B, and C are in one line, then these points we say they are collinear. Why? Because they lie on the same line. Okay, and also note that vectors formed between collinear points are parallel to each other. What do we mean? If these three points are collinear, if I form vectors between them, these vectors are parallel. So if I form vector AB, so this is that if you join A and B, we shall form a vector AB, and if you join B and C, we shall form a vector BC. So it means that AB is parallel to the BC. This is what it means. That's why you see that we have a constant here. So AB will be parallel to BC, or AB will be parallel to AC, because AC is also a vector formed between A and C. This is the case. Or BC will be parallel to AC. As simple as that. Okay, that's what we mean if two vectors are parallel, or if three points are collinear. So let us see how do we show. Given that vectors P is that and Q is that, show that P and Q are parallel. So what we need to show? We need to show that there is a multiple K or alpha that we can express so that this one is in terms of the other. So you see that from here my vector P is 4, -2, and my vector Q is 2, -1. Now, you always make sure that this vector there is no common factor to these two. So it's that this one is having a 2 and this one is having a 2. So if you factorize out a 2 out, you see this one, and I factorize out a 2, I'll be having a 2. When I factorize out a 2 from here, I'll be making with -1. So this will be, your P will be 2 into, but we have seen that the whole of this 2 -1 is Q, like this. And so this is P equaling to Q. And so now our K this time is going to be 2. This is what we mean. Now is that P is a scalar multiple of Q. So therefore P and Q are parallel. Even if you got a third, as long as these two can be having a scalar multiple, that is okay. Okay. So another question, show that the points A, B, and C are collinear. What do we need to do? We need now, they are giving us these points. That's our solution is here. They are giving us that points. We have points A, B, and C. If they are collinear, we said if they are collinear, vectors formed between these points are going to be parallel. So we need to show that the vectors formed between them are going to be parallel. What do we start with? It means that I can form vector AB. So I will form vector AB, the vector formed between A and B. By that one will be OB minus OA. So this is point B, then this position vector will be from vector -1. Then minus OA, which is, and you see if we simplify this, we get 3 minus, we get 4. Then -1 minus 5, that's -6. So this is my vector AB. So you need to form any other vector. So then you form vector BC. So my vector BC is that my BC will be OC, then minus OB. This OC minus OB. So my OC, the position vector for this, then minus OB, my OB, and so this one is going to give us negative minus this, we get negative 8. Then 11 minus minus, we get a positive 12. Now, your question is, can you express this in terms of this? Now, you see here that this one is almost similar, but this one is positive, yet this one is negative. And so there is a 4 inside. So what you do, you factorize out something which is negative, and also, so that when you factorize that out, you remain with the 4 here. How am I going to do that? You said my ABC will be equal to negative 2. Why am I factorizing not negative 2? I want this to be a positive. So when I factorize out negative 2, here I remain with a 4. So when I multiply this and this, I will be getting negative 8 back. Then, because this is positive and if you remove a negative, it means that what remains with should be a negative. So this will be now negative 12, this 2 divided by 12, you get 6. You see that when you multiply this back, you get this negative, negative, you'll be having a positive 12. So this will be now negative 2 into now, the whole of this is that it's the vector A, B. And so now your BC is equal to negative 2 A, B. Now, because you have shown that these vectors formed between those points are collinear, it means that, it means that since BC and AB are parallel, then A, B and C are collinear. That's how you conclude with that. I wish you the best.